All right, everybody ready?
To my side.
All right, so we are going to start talking about trig. Okay, that's the short for trigonometry. And trig is, the study of trig is more like it, involves triangle measurement. Meaning side lengths and or angle measures. So that's what we're going to be finding with trig. Okay, we did our special right triangles, and we did the Pythagorean theorem. But the trig aspect is going to bring angles and sides together. So a trigonometric ratio is a ratio of the lengths of two sides of a right triangle. I'm trying to put that all together. Okay, so a trigonometric ratio is going to be a ratio that compares the lengths of the sides of two sides in a right triangle. Everybody ready? So each acute angle in a right triangle has the following trigonometric ratios. Now, first of all, let me tell you what I'm talking about. In a right triangle, you have one angle that's a right angle. These other two angles are going to be acute, which means they're what? Less than 90, okay? So they're calling them acute angles because the other two angles, not the right angle, but the other two angles in a right triangle are going to have trigonometric ratios. Now, the first one is called the sine, S-I-N-E. But it is abbreviated as S-I-N. That's not sin, it's sine. Okay, and when we get to the calculator portion of this tomorrow, you'll see it written on your calculator. S-I-N, that means sine. Okay. And that is the ratio of the leg opposite the angle to the hypotenuse. Pen's not wanting to write. Okay, so the ratio of the opposite leg, opposite of whatever angle we're referring to, and the hypotenuse. And the hypotenuse is always the same, right? It's the side that's across from the hypotenuse is the side across from the right angle, yes. Okay. Label it. We say we don't know. Okay. And then erase it for the next one and relabel. All right, so look at angle A in your picture. Does everybody see angle A in your picture? Okay, so what we're doing is we're focusing on this angle. What I want to know is what is the side across from angle A labeled as? Directly across the triangle, what is it labeled as? A, okay. So the sine of A is going to be a lowercase a in this picture over, what is the hypotenuse labeled as in that picture? C. Okay, so in this particular picture, the sine of A, I'm going to go back to the picture, is the opposite side, you see I have it highlighted, over the hypotenuse, and the hypotenuse never changes.
What does that mean?
Sine.
What's that mean?
It's the ratio of the opposite leg over the hypotenuse. Okay. Now look at B. Let's do the same thing, but for B. Okay, C is still my hypotenuse, correct? All right, so let's look at angle B. What is the side directly across from it labeled as? B. So in this picture, the sine of B is going to be B over, what did we say the hypotenuse was? C. Now, it's not going to be always A and C. It's going to turn into numbers, okay? But right now, we're just kind of showing you the relationship across the angle opposite over the hypotenuse. Okay, do you see how it's written as S-I-N? That is sine, not sin. We just take the E off to abbreviate. Sine is what? Two legs? What over what? In words? In words. What did we fill in? Sine is opposite over hypotenuse. Okay. Now, the next one is called the cosine. It is spelled C-O-S-I-N-E, but when we abbreviate it, it is just C-O-S. That is cosine. That is going to be the ratio of the leg that is adjacent to the angle. What does adjacent mean? Next to, okay? Not opposite, but adjacent to. So not across the triangle, but next to the angle. And it is also over the hypotenuse. Okay, so cosine is adjacent over hypotenuse. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Let me draw my picture so I don't have to keep going back and forth. This is A, this is B, this is C, it's lowercase a, lowercase a. Cool. All right, so the first one wants us to look at the cosine of A. So here we are focusing on A. It is the adjacent leg. Okay, remember the legs are the two that make your right angle. So which one of my legs, I have leg B and I have leg A, because C is the hypotenuse. Which one of these is touching A? B. Okay, so the cosine of A is going to be B over, what is the hypotenuse again? C. Okay, so the cosine of A is going to be the side B over C in the picture that is to the right. All right, let's do the cosine of B. Looking at B, again, I want the leg that is next to B, not the hypotenuse, but the leg that touches B. Which leg touches B? A, okay, so the cosine of B is going to be A over, what's the hypotenuse again? C, yeah. Sorry. A over C. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. The third trigonometric ratio is called the tangent. Okay, tangent. T-A-N-G-E-N-T. That is abbreviated as tan. Okay, so when we get to the calculator version, S-I-N is sine, C-O-S is cosine, T-A-N is tangent. And the tangent is the ratio of the leg opposite the angle to the leg that is adjacent to the angle. Opposite over adjacent. So if we do the tangent of A, okay, let's look again at angle A. What is the side directly across or opposite from angle A? Lowercase a, yep. And then what is the leg that is adjacent to angle A? B or C? It's a leg. B, yeah, okay, so C is the hypotenuse. So the tangent of A is going to be the sides A over B. Opposite over adjacent. And then we're going to do the tangent of B. be? What's the side directly across from B?
B.
And what's the leg adjacent to it?
A.
So the tangent is going to be B over A. So those are the three trigonometric ratios. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So I have a little trick that we can remember that by. Okay, so first of all, sine is opposite. I'm just going to abbreviate because that blank is not big enough to write the words. Over hypotenuse. Okay, look at the first three letters of each one of those. What's the first letter of sine?
S-I-N.
The first letter.
S.
S. And then the first letter of opposite is O, and the first letter of hypotenuse is H. So in that blank above that little bubble, write S-O-H. This one is always the one by itself. Go ahead. You have another one. Just look for it. You can get X by itself and it takes it already. Okay, we're writing S-O-H at the top. Yep, that's the actually here. Okay. A squared plus B squared. All right, cosine. What is the ratio of cosine? What two sides? Adjacent. Okay, ADJ for adjacent over the hypotenuse. Let's do the same thing. What's the first letter of cosine? C, first letter of adjacent. A, and first letter of hypotenuse. So we're going to put CAH at the top. Mine didn't write an H.
What's the A for? Oh, adjacent.
Okay. All right, and then tangent. What's the ratio for tangent? Opposite, yep. Over adjacent. First letter of each, what would that be? T-O-A. Okay, so that saying at the top is SOHCAHTOA. SOHCAHTOA is how we say it, and that helps me remember, and that should catch up with me in just a second. I've been writing, but it's not writing. There, it's not. Oh, no. Hold on. There we go. Okay, so you'll see those letters, S-O-H, C-A-H, T-O-A. That is called SOHCAHTOA, and that helps us remember our ratios. Sine is opposite over hypotenuse. That's what the O and the H represent. Cosine is adjacent over hypotenuse. That's what the A and the H represent. Tangent is opposite over adjacent. That's what the O and the A represent.
All right, so Ms. Bridges?
What do you remember?
Yeah.
Are we ready?
I got a question.
What?
What does C-A-H stand for?
Cosine is adjacent over hypotenuse. Sine is opposite over hypotenuse.
Okay, I was testing you. Okay.
All right, let's look at this first picture. Do you notice that we have sides labeled 13, 12, and 5? Yes. All right. We're going to start with writing the ratio of the sine of angle A. And when we write these ratios, if they can reduce, we need to reduce. Okay, keep that in mind. So let's look at angle A. Again, sine is opposite over hypotenuse. So what is the side length of the side that is directly across the triangle from angle A? Directly across? 5. Okay, so that's going to go on the top. What is the length of my hypotenuse? 13. Okay. So my ratio for this triangle for the sine of A is going to be 5 over 13. Can that reduce? Do 5 and 13 have anything in common? No. Okay. Then we're going to do the cosine of A. Everybody ready? All right, still focusing on angle A. Cosine is the adjacent leg over the hypotenuse. Which leg is next to angle A? 12. Okay, that's my leg. So that goes on the top. And then it's over the hypotenuse, which we already said was 13. Do 12 and 13 have anything in common that I can divide out? No. All right, try the tangent of A. Tangent is opposite over adjacent. The tangent does not involve the hypotenuse. So try to write the ratio of the tangent of A. Opposite over adjacent. What is the side that is opposite angle A again?
5.
Okay. What is the side that is adjacent? 12. And then can 5 and 12 reduce? No. Okay. So what I want you to do is I want you to take a minute and do the sine of C, the cosine of C, and the tangent of C. Do those next 3 questions. I'm going to let you try those. We're writing ratios. If they can reduce, reduce. You have the words right above. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Yes. This is this. That one is for that. Make sure you do that. So for this one, if AB is 8, BC is what we're looking for. So you call that one X, right? So X is finish that one. All right, are we ready? So for C, what is the ratio of the sine of C here? 12 over 13, yes. Okay, remember here's C, opposite over hypotenuse. The hypotenuse doesn't change, right? The hypotenuse is the same no matter which angle we're looking at. All right, what about the cosine of C? What would that be?
5 to 13?
5 over 13, yep. And then the tangent of C would be 12 to 5, opposite over adjacent. So far, so good? Okay. Look at number 2. Do we have all of the side lengths labeled in that triangle? No. So before I can write a ratio, I need to actually find that missing side. What was it that we did on the quiz yesterday when I had two sides and needed a third side? We didn't do a 45-55 or a 30-60-90 because we don't know what the angles are. But we're going to call that x, and we're going to do the Pythagorean theorem, right? Which one of those is the hypotenuse? The x. So what we're going to go is 9 squared plus 12 squared equals x squared, and I'll do the work since you don't have your calculators. Okay, you need to write the problem down so you know what we're doing. I don't have a 7 anywhere. That's a 9. All right, 9 squared is 81. 12 squared is 144. If I add those together, I get 225. Okay, I'm doing the work for you because we didn't get calculators. Then I have to take the what of both sides? Square root. And the square root of 225 is 15. Okay, so change that to 15. Now write your ratios, all 6 of them. The sine of W, the cosine of W, the tangent of W, and then the sine of X, the cosine of X, and the tangent of X. These can reduce. Okay, so we need to write them and then reduce. If you need the calculators to reduce, you're welcome to go grab one. What's in the same place in February? You should be writing ratios, not talking. That's why it's hard, because you don't try. It's the same thing that we just did on the first. It's 8, right? AC. What is in the same place in that triangle? Same place. More X's. We should be writing ratios. I should not see these answer blanks being. What's cosine?
And after tan, it's tan.
And it is opposite over adjacent. Your angle is opposite. Okay, so that goes on top.
Then
What's the next to adjacent?
adjacent,
Not the hypotenuse, but the adjacent.
I was this one.
Yes.
And then come back, one more.
No, you can do those. You can do it. just be x squared to 2 equals 6. All right. Sine of W. We're looking at W. That's the angle that we focus on. Sine is opposite over hypotenuse. What is the opposite of W? 12. And what is the hypotenuse? Okay, the hypotenuse is not going to change. The hypotenuse is going to be the same number for every sine, cosine in this triangle. Okay, the hypotenuse is always 15. What will change is the opposite and the adjacent based on which angle you're looking at. Now, 12 over 15, they can both divide by 3, correct? So that's going to turn into 4 over 5. Then we're going to do the cosine, which is adjacent over hypotenuse. What is adjacent to W? 9. And the hypotenuse is what again?
12.
15. And 9 and 15 can both divide by 3 again. So that's going to give me 3 over 5. Then we're going to do the tangent of W. Tangent is opposite over adjacent. Opposite is?
12.
What is adjacent?
9.
And then they can both divide by 3 again. So that gives me 4/3. Is everybody okay with that? All right, now we're changing to a different angle. Whoops. This time, we are going to be looking at angle X. Okay, so sine of X, opposite over hypotenuse. What's opposite X? 9. And the hypotenuse is still? 15. Divide them both by 3 to get 3/5. I did. Look at my highlight. Do you see that 9 is directly across from X? Then we're going to do cosine, which is adjacent. Which leg is adjacent to X? 12. And the hypotenuse is still? Okay, those can both reduce by 3 again, so that's going to give me 4/5. And then we're going to do tangent. Tangent is opposite over adjacent. What's opposite of X again? 9. And then the adjacent is 12. 9 and 12, again, can both divide by 3, so that's going to turn me into 3 over 4.